So I said that this presentation is a journey, so you can't have a journey without a starting point and a what is the current state. So I'm going to contrast a fair bit about what was the state at Netflix in 2010 and what is the state now. And the reason I'm picking 2010 is that's when I started at Netflix. I'm an old timer at Netflix, 9 years now, so that's what I know. And I still work there, so I know now as well. So let's start with what is the business? How has it changed over time? And it's pretty radical as you watch this build. So we were a DVD company when I started. That was the lion's share of our revenue back in 2010. And if you were a DVD subscriber, or if you still are, you might have a special warm place in your heart for these DVD mailers that probably many people got. Then we have streaming, and that was there. I didn't start it. I can't take any credit for that. But it was very formative. It was a really small part of our business. I remember our CEO, Reed, kept pushing us, don't focus on DVD, even though it was the big lion's share of the company, because he saw what is ahead and what we had to do. Then we got into international. We did not go DVD international. It was only streaming, so it started with Canada. Then we went into license original, which was a big change for us at that point. Before that, it was always taking what was available in the market and then sort of repackaging it and delivering it to our customers, either through DVDs or online. But now this is first run on Netflix only. Next was original production. So we started from scratch, building our own shows, getting the pitches and the like. And then the latest incarnation of Netflix is international original production with lots of productions all across the world. So this is a very different business than I started at. The nice thing is that the tech DNA has not gone away. If anything, as you'll see shortly, it's just gotten stronger and stronger over time. So what about on the people side? So on the people side, it was about 2,000 people when I started, about 6,000 people now. It's a little bit of a misleading number, especially on the engineering front, because we have a lot more Hollywood people, people that are buying content and are producing shows. So there's a lot of people involved there. Plus, we're very international now. We have a lot of offices around the world. That being said, engineering is almost all focused in Los Gatos, here in the Bay Area, with a bit in LA to support the content folks. And one little call out for this slide, this is a real room at Netflix. We do have these little circular gladiator type rooms here. I will say no engineers would ever cluster in the inner circle and talk. So you can tell, obviously, this is a stage photo. They'd be like spread along the outer rims. And then the data platform. What was the data platform? So 2010, this is when I started. We had a 34 terabyte data warehouse in Teradata. We had about maybe in the single or tens of millions of data events logged every day, so information about DVDs and some light information about streaming. Contrast that to now, well over 100 petabytes of data in our data warehouse and over 1 trillion new data events logged per day. We stopped counting after we got to 101 trillion. So, well, we do count, we just don't talk about it publicly. So, and these events, the data events, the 1 trillion, these are things like, are you hitting play? Are you hitting pause? What A/B test cells are you in? What's your video quality that you're getting? What are you doing in the UI so that we can optimize the experience for you? That's why we collect all this information. The nice thing is we get to keep it all internally. We don't have some of the problems some other companies have where they do a lot of sharing with other companies. This is just about making the user experience better. Then we have the tech. So when I started, it was a very traditional business intelligence stack. It was Teradata for a data warehouse, Ab Initio was the ETL or transformation tool, and MicroStrategy was for reporting. Fast forward to today, we have Spark for ETL, we have and some querying. We have Presto for the lion's share of our querying. We have Tableau for our reporting, and we have Flink for stream processing. And we have Druid for interactive, large-scale analysis and as a backend for some custom reporting tools. We have Pig, which I've grayed out because it's come and almost gone in that time. Hive is just about gone. I didn't even put on the slide. We have Cassandra as our data stores. We have Genie for our execution service. We have Metadata, or Metacat for our federated metadata services. We have Kafka for our data pipeline. We have Jupyter for notebooks. Snowflake when your data stores won't quite cut it in Presto and you need better interaction with Tableau, for example. And Mantis is an internal stream processing system. So it doesn't matter for you guys, these particular technologies. What I really wanted to illustrate, though, is, and this is nothing compared to the extent of tools that we have. What I want to illustrate is this is super enabling. You can do so many things you couldn't do with this richness of tools, but it's also could be confusing and exhausting for our users. So it's really important how we actually expose this to somebody so that they can operate in a self-service fashion. As far as the team, the data platform team, so back in the day, not including myself, it was a team of 4. And not surprisingly, we have 4 things. So there were 4 different people doing different things. So we had an ETL person, a reporting person, a DBA, and then we had one guy, we weren't exactly sure what he did, but it was useful, and we just called him the tools guy. Now we have 80 people, and it's not the same platform as before. You saw the technologies I mentioned, but it also is many new areas we didn't do before. So MLI, machine learning infrastructure, real-time data infrastructure, user experience, big data compute, big data services, and on and on and on. Depending on the company that you work at, this could seem really big or really small. It's epically small when you actually break it down to what people are doing. So the big data compute team, for example, is a team of 8, and they support and they contribute to and sometimes use Spark and Presto and Snowflake and Hive and Pig and Druid, and they do capacity planning, they do all sorts of other responsibilities. So the fact that 8 people can do that is pretty mind-boggling to me. The reason they could do it is they're all experts in their field, and then the people that they're working with are usually quite a high level of expertise as well. And then there's me. In 2010, this is what I looked at, and this is what I look like now. So obviously I have not aged gracefully in the last 9 years, and I've lost a lot of hair along the way. Actually, that was my 7th grade photo, so forget that. Now let's do a deeper dive into our technical ecosystem and how we're applying this user-centric self-service mindset that I've been talking about. So one of the hot topics that you can't talk at Strata without talking about machine learning is my team supports machine learning infrastructure at Netflix. We spun up a team about 2 years ago. Now that might immediately be like super confusing for me to say something like that, because isn't Netflix known for machine learning, recommendations, all that? And yes, we've had a machine learning team and we've had machine learning infrastructure people for a really long time, but they were really focused on the JVM. They were focused on high scale, user-facing, really gnarly problems that you could spend a lot of time sort of working through all the kinks. But what was underserved was what is now the data scientist, somebody that is more internal facing, a little smaller scale, and it's still really important what they're doing. So it might be that they are trying to figure out how much should we pay for content. We're spending billions of dollars for content, so it's pretty important we get that right. Or doing fraud analysis, or all these other sort of one-off things that using the JVM is just way overkill for. So we spun up this team. Now, some of the principles right from the get-go when we're spinning up this team, which is probably different than some other companies approach this, is that we really decided, like Netflix style, we're going to meet our users where they are. So instead of saying we're going to create this, snazzy, huge machine learning machine that as long as you use these 6 algorithms, as long as you do it in this way, then it will be productionalized. Oh, but you want to do something a little different? That doesn't fit. It'll take 3 months to do it, or you just go off and scrappily do whatever you were doing on the side anyway. So we're saying we're not going to do that. If people are going to use Python and R, for example, we'll make them first-class citizens. We won't make them relearn everything they do in order to do machine learning at Netflix with our team. Part of that is simplifying the integrations. So, the benefit that they'll get is that before we were doing this, they were pretty much on their own. They were using our data platform anyway, but they were rolling up their sleeves and figuring out whatever and doing all sorts of tech debt all over the place and solving problems. But it was really hard. They had to sort of reinvent the wheel over and over and over. So we wanted to say, hey, if you want to work with our container management framework, just do this. If you want to spin up a notebook and tie it into a Presto query, here's one line of code to do it. So that we really focused on that, and that's part of meeting the users where they are. And then finally, we do have aspirations that eventually there will be higher level, shinier machine learning systems, and there are some at Netflix. But we're really focusing on the building blocks. Get those right, get what people actually want in front of them. They will use that. We can keep building on top of those, stitch those together. Eventually, it might be like, hey, you want AutoML and a bunch of things, you're not even sure about the data. Well, we will have built all the fundamental building blocks, and we can provide that as one of the offerings if it makes sense for the use case. So the best example of this in action is Metaflow. So this is our machine learning infrastructure framework, or our tool, might be a better description of it. And this has been super powerful at Netflix. One way to use it is in Python. It has a little bit of an opinion. Anytime that you want to accomplish something, you typically need some sort of opinion, at least in a cohesive fashion. But again, we want to make it really easy in terms of whatever code you'd normally write in Python, instead of just making a long script that's sort of garbled all over, break it into steps. Each step is independent of the others, and each step gets checkpointed and even written to disk. And then you have a start thing, and then you can sort of stitch together a DAG using these next methods. So, but to run this is a real bit of code. Doesn't do a whole very useful set of things, but it sort of shows the flow of what you could instead throw in some TensorFlow code or throw in some scikit learning code, scikit-learn. Similarly with R, it looks almost the same. You can use R if that's what you're comfortable with in a very similar paradigm, and it'll tie into some of the same stuff on the data ecosystem behind the hood. Now going a little bit, here's some actual real code in here as well, is that, again, toy example, you could just throw in a machine learning library if you wanted to, here's an example that the automated niceness this gives for you. So if you've already run this before and you say resume at step B, then it won't restart from the beginning. It will have checkpointed each of the stages before, and if you had a really big Presto query that took 2 hours to run, you can just use those results. And we've done a lot of stuff under the hood where it's like, hey, as we're checkpointing these things, let's take a hash of the data and just store it once and just reference that same set of data the next time. And it's amazingly small, actually, how much data gets persisted by this thing. And then we have cleanup processes periodically to get rid of old data. Getting a little bit more real here. With these decorators in this code, you could say, hey, we actually don't want to just run this locally. We want to fan off this job onto Titus, which is our containerization management framework. So the user doesn't even have to know where is that thing and how do I connect to it and what's the DNS and how does it work exactly. They just know that is a resource manager somewhere that they could spin up an instance with 16 CPUs and 1 GPU, or 200 gigs of memory, or you could actually in parallel spin up 1,000 containers if you need to do grid search or something in machine learning. So that's a super high-level tease of machine learning infrastructure. Probably the best exemplification of self-service is our portal. So this is the one-stop interactive stop for how to work with our data platform. We're really making it simpler and simpler and simpler over time. The latest iteration brings in universal search. So instead of it being more of a browse experience where you're trying to figure out, like, what else can you do in this portal? You could say, like, hey, I just want something. I added date is what I was searching for. And it starts pulling up multiple resources across queries and tables and workflows and reports and other resources out there. And it has like sorting algorithms and filtering algorithms. And you can say, I want to optimize filter that gets rid of a lot of like staging tables, or you can say, I want everything if you're a developer. So this is pretty much the ultimate in self-service here. Another big part of the portal, probably the bread and butter of the portal, is this query pane. You can go to multiple engines, a drop down there under the query pane for Presto or Spark SQL if you wanted to, or what cluster you want to hit. On the right side, there's a schema browser. If you go down to the middle, there's a whole bunch of things that, this is again now to the self-service and user-centric. People just kept asking for some of the same things over and over and over. So we added a download capability, and most recently we added a publish to Tableau capability, where it's like, hey, you've written this query and you want a data extract out of that. Like, can I just do it now where I am? And I'll talk about that in detail a little bit later. And of course, you have the results at the bottom. We also have some designers on the team, so we're actually starting to get some slicker looking UIs. So this is a little more formative. This is where our workflows might go in the future. This is made up right now, but it's a much sort of easier to digest experience. You don't have to worry about the details on it, but if you're a user and you're just trying to figure out what you need to do, you don't have to stumble across as much over the lack of design talent that most of us engineers have, including myself. So here's some principles for the portal. So rich metadata, you really can't get away with, you can't get far without having rich metadata. So in order to have search and facets of diving into your platform, or how long should this partition live before we auto clean it up, you need to add a lot of metadata. Iterate, we've been working on this portal for years and just keep getting better and better, and what does a user really need and what isn't smooth, and trying it ourselves and what do we think about it. And then that ties into a virtuous cycle that gets created, because the more features we add to the portal, the easier it gets, the more people use it, the more we want to add features, the more people want to use it. So it's a really nice cycle that gets created. One thing that's easy to underappreciate is all the little things. So forever people were asking us, like, they just want to see sample data for a table, and the engineers and us were like, come on, you could just do a SQL query, limit 10, top n, but then is it limit 10 or is it top n, whatever it is. So there's an example where it's a little bit of cognitive load for somebody to figure it out. So we added that, and that was like one of the most popular features. Hey, I can see sample data. Things like that, but also even the iterative nature of working on the portal, it buys yourself credibility. And that's really important, because we want to do some of those big bang design things I said. But if you say, hey, hold the phone, I'll be back in 2 years with this super slick portal, like, you'll be gone. So instead, it's a combination of those two things. It's both iterate with what you have and then do some of these big bang, rethinkings over time. And then that ties to that last point of engineers not being designers, that you really need, if you want it to be slick, you don't need to. We got away with years without having that, but eventually you really want someone that has the right skill for the job. But we do code too at Netflix. It is not just portals and machine learning, because machine learning is pretty code-centric. For early days, we created something we called Kraggle. It's from the Lego movie, not a good name. I'll talk about naming later. And we also call it the Big Data API, probably a little bit better name, even though it's not really an API. But with a couple lines of code, you can do just about anything on the data platform, because we've wrapped it in Python. So you can import Kraggle, and then you can run this transport method to move data from, say, our production, it says prod hive, but I call it our S3 data warehouse, into Snowflake, for example, just in a toy case. But 2 lines of code, real, this could work. More recently, we really are investing pretty heavily in GraphQL. This is kind of an eye chart to you. I'll share the slides later on. But if you don't know what GraphQL is, many of you probably are using it actually, but you can think of it as like a query service, or a query language, I should say, for APIs. So it's you get many APIs there, and you can have this language where you say, I want this thing, but you're really abstracted from the actual APIs themselves. You just think of things as a resource. So this example, I'm saying, hey, I have this table, geo country D, and I want to know who is the owner, and then who are the peers at Netflix of that owner. Now, that's a very easy intellectual thing, but that's a very complicated technical thing, because, well, tables, that data is in Metacat, and then people's relationships is in Pandora, some completely different organizational system. But to the person using this, they don't have to worry about that. We do that stitching of things behind the scenes. And nothing special about us in this case. This is what GraphQL does. But we really are starting to layer this on top of the many resources we have at Netflix, whether it's tables or workflows or queries, and say, hey, if you want to find this thing, then here's this resource. And the beauty of it is that not only does it do the heavy lifting behind the scene for you, but it also only brings back what you need. A lot of APIs are very verbose, and sometimes, for example, on JavaScript interactions, that can be really heavy, but it's really light with GraphQL. And then we're also going to take Kraggle and kind of stuff in GraphQL underneath the hood. So instead of Kraggle doing all the things directly, a lot of it Kraggle will call GraphQL, which will then do things on your behalf. Therefore, you don't have to just use Python. You could use other things like a Java client using GraphQL. So some of the principles here on code is obviously you can choose your own adventure with code. You can do anything with code. Whereas if it's in a UI, you're going to be limited to what the designer had set out that you could do. And that might work sometimes, but it doesn't quite often. Self-service, and this again a broader theme, does not mean expertise-free. You're still going to have to roll up your sleeves sometimes if you're doing complicated things, but the easy stuff should be easy. It provides abstractions like that transport module that I'd said before that lets you move data between different things, or just saying, hey, I want the peer of this person when you don't even know what systems are involved. And then this heavy lifting is handled for you. Another great addition over the last few years at Netflix, and again, I'm sure many of you guys are using notebooks. So Jupyter, we use Interact, which is part of the Jupyter umbrella, pretty heavily at Netflix. Again, iChart, but you can think of this it's a great place that you can do your code, you can add comments, you can do visualizations, you can do reproducibility easily because it saves the code and it saves the comments and it saves the results. You can do collaboration with these, so it's a really rich and powerful environment. And here's our friend Metaflow again. Hey, it just tied into this notebook ecosystem. So you might have run a job before, but now you can import the flow that you've already run in Python somewhere on a CLI, for example, and fire up a notebook and say, hey, I want to pull up this latest run 3, and I want to inspect what are the steps, and I want to know what are the results of the different stages. And this didn't require any execution on like a containerization, like heavy duty framework or anything. It doesn't rerun the results, it just gets the data off of S3. As I said before, it just checkpoints it along the way. So this Jupyter and Interact ecosystem that we use heavily, we've been contributing to it. Papermill is a way to programmatically execute notebooks using parameters, and I'll talk about how we use that for scheduling soon. Bookstore is a way to auto-save your notebooks, so that's a common complaint if someone's not using the whole Git ecosystem. They might be just scrappily working along and they're like, oh, can you get me that version I had earlier today? And we're like, no, we have no idea what that was. But this will automatically save it to S3, and it uses version buckets on S3, so we actually get versions for free. And then Commuter is a way of seeing read-only versions of notebooks that you can then share with people with a simple URL and clone it so they can start executing it in their own environment. And there's many more parts of the Interact Jupyter ecosystem. M-Pacer, who's at Netflix and is actually on my extended team, is going to be presenting later. So if you're interested in that, you should definitely check it out. So some principles in notebooks is weave it into your world. You saw the Metaflow example is that they had their normal world, but hey, isn't notebooks like, it was a great environment to introspect the results. It also lets you reimagine how you do things. So you might have just been like, oh, I'm so used to using a CLI or using this other tool, but a notebook is such a great way of sharing your insights and having the graph embedded in there and not rerunning the results every time. And then finally, when it doesn't work for you, extend the ecosystem. And that's an example of what we've been doing with Interact. On the scheduler front, this was another one where we had an enterprise solution. A few people really loved it. Most people really didn't like it. But it was an enterprise tool. So it forced you to learn how to do things based on how it did things versus letting us craft it to meet the users where they are. So eventually we said, we need to get off that scheduler. We need something more programmatic. And we ended out on Meson, which is actually a scheduler that a different team other than mine created. And I'll tell you shortly why we ended out settling on that, say, versus something like Airflow. So this portal, as I said, now we have programmatic control. This is an example in our portal. Again, that center of gravity that I mentioned before. We can adapt this however we want to give people an easy to digest experience about their workflows. Hey, there's Metaflow again. And if you want to schedule a Meson job, a schedule job in Metaflow, all it is that one line of Python. And then it takes all those steps and it turns them into steps in a DAG on Meson. It can run on Titus, our containerization frameworks. Again, all this abstraction and this sort of self-service done for you. The approach that is being taken for Meson, there's lots of ways that you can do scheduling, is it uses YAML files. Typically you'd refer to an external file, but here for simplicity, it just embeds a SQL statement that is filling in new data in a table. You could just upload a YAML file. Typically people would go through the whole GitHub workflow, but if you're not that technical, this is a way to work with the scheduler, meeting you where you are. It let us add things that we wanted to add, but we couldn't do it in our old scheduler. So WAP is our write, audit, publish flow. So it used to be sort of like, hey, you're running an ETL job and you add a bunch of data and maybe you're querying that data, that table right while somebody's adding data to it, and you could sort of get indeterministic results. But now instead it says, hey, we're going to write the data in our ETL flow somewhere else. We can audit it, because even worse, it might be completely wrong and throw off reports. And then we publish it over. And by having this new paved path and center of gravity in Meson, then we can just add additional code that lets you do this pattern. Both the write, audit, publish, and data auditor, which is our auditing framework, where it has a lot of pre-can audits where we can add our own, in this case, that should have a certain number of rows you're expecting per day. And then you can have blocking audits or non-blocking audits. Back to super self-service, and something I referenced before is this higher level of abstraction. So in this case, some really non-technical users might be like, I understand how to write a query, but I don't understand any of the rest of this data ecosystem, but I want to start using Tableau. And that was that button, Publish to Tableau, that you saw before, where now you just get a pretty UI that says fill in a few parameters. You can do it time-based or you can do it data event-based, and then it will automatically every day or whatever interval create that Tableau data extract for you. And then notebooks. Notebooks are everywhere. We're sort of putting it underneath the hood in these reimagined sort of ways. So I said before, Papermill does parameterized notebooks. Every scheduled job we run is actually a notebook that's being executed. And the reason for that is that, well, the scheduler doesn't care, but when something goes wrong, or you want to understand what did it actually do, it'll save each run of that thing in a notebook, including the logs and results. So if something goes wrong, you're not doing the treasure hunt all over the place. You can just go to that notebook and go, what happened in these different steps? How far did it get along? What should I tweak in some cases? Can I inspect the data in some cases? And then you could fix the main flow or re-execute that notebook if it was a crisis. So some learnings here is do the work once. So the reason that we ended up consolidating with Meson versus taking on an external tool is that they'd already done a lot of the work integrating with the Netflix ecosystem. If we brought another tool, we were going to do it again. And actually, there's like 5 other schedulers at Netflix that also had done that work, or they did their version of what they just had to do. And then the sad thing is that it meant like one after the other scheduler or workflow manager was being created because there was no center of gravity. There was not like one tool that, well, of course you go here and we just extend it a little bit. It would have been more like the content engineering team talking to the personalization infrastructure team and saying, can I use your scheduler? And it's like, it's just kind of awkward. But if you're like, this is the scheduler for Netflix, by creating a center of gravity, then everyone benefits and can use the same code. It also minimizes the cognitive load for users because a lot of these users do actually span different workflows. The recommendation folks also use the data platforms. They had 2 schedulers to work with, actually 3. A sort of learning in general about both this, and I'd say more generally, is don't take away what's working. When you bring in something new like a scheduler or a data auditing framework, don't say you can't use your working data auditing framework, because that is just going to give you nothing but friction. Start with people that have nothing or theirs is bad, and then co-opt the best features from the ones that are good, and then leave those other people alone for a while until you get it right, and then eventually say, hey, but by the way, we do what you did, and we have like 10 other integrations with the platform, and it's so much better, and then they're happy to come over instead of like a death march over to yet another migration. And go with and to the flow. A little pun, I suppose, for Meson is that, in this case, we had that flow, we had that YAML code, so it was the perfect place to add this WAP and data auditor code, whereas before we had no great place to put it, or it would be in a separate system and people wouldn't do it. So I'm going to do a quick digression into a public service announcement. So hopefully this is worth its price of admission right here by saving cognitive load from people in your company. Whatever you're going to call that system, don't call it that because it's a terrible name. I can just say that already pretty much almost definitively. So this is a famous internet quote, is there are only 2 hard things in computer science, cache invalidation and naming things, attributed to Phil Carlton. And that is true. We're terrible, most engineers at it. I manage the team, but I'm also an engineer in background, so I kind of play it both ways. So here's the principles, I would say. Clear is better than clever, which is not how most people think when they're naming it. And here's the hierarchy, I would say. If you hear the name and you know what it actually is, data auditor. Great. What does it do? It audits data. You hear it, you're told what it is, and associated is cemented. It's not quite as good. We have something called Caspactor, which is the way that we get data out of Cassandra. We crunch down the data, and we make it available in the data warehouse. You all know what Caspactor is now, even though you had no idea what it was before. You might remember Cassandra, something like that. Maybe you won't. Maybe not the best name. It's in a theme. R2D2, C3PO, those are our CS tools. I have no idea what those things are. I know they're in CS, that's CS customer service. That's the only thing I know about those tools. And then finally, I have no idea what that thing is. And that's the typical reality. Is it Aegis or Astyonics? And are those even around anymore and what they do? And those are both real names of real projects at Netflix. And that's the sad typical reality. So I'm not defeatist here. What do we do? Well, here's some tips on naming things. So bonus, price of admission. So first, brainstorm, what does the thing actually do? Like list those things out. It audits data. Ooh, and you like data auditing and quality and checks, and get all those words and see if you can stitch them together or conglomerate them or find synonyms for it or find metaphors for it. At least you'll hit one of those top 2 marks. Let it soak a while. Sometimes it's hard at first, but then like a week later, you're in the shower, you're driving to work, you're like, I've got it. This is what the project should be called. Delegate it. That's probably the best answer. And this sounds kind of flippant, but some people are actually good at it. Most of us are not. And then give it to them. So maybe in the second category, we had something that was a visualization and insight tool for Pig that we created. And it wasn't my team that named it. It was someone else that just had an insight. They called it Lipstick. And it was like, at first I was like, oh, if you can own that to the person who owned the project, like it's your decision. And now I love it. It's just like a lipstick on a pig, and it's like visual, and again, you have to sort of know the analogy and a lot of other stuff. But it's not quite as good as Data Auditor, as boring as the first one is. And then finally, don't name it. Like that's probably the most valuable thing, is when you give something a name, it takes on a life of its own. People suddenly love it, and they can't get rid of it, and they want to extend it, and then it's like Metaflow Hosting almost had a name at one point. I'm like, no, don't give it a name. Call it Metaflow Hosting or hosting within Metaflow, because otherwise it's like this thing. Whereas it might be that we just, let's not make it part of Metaflow. Let's just have something hosting, or let's just have an application server somewhere that does hosting as well. But as soon as you have a name for it, it's like it just lives forever. And finally, we have education and support. So as great as the tools are, if people don't know how to find it or how to use it or how to get help when they do need help, then you're being super inefficient as an organization. So we have recently embarked on this journey. This was about 5 months ago. I hired some developer education people, and we created this page, Go Data. And at Netflix, we have this thing called Go Links. You guys might have something similar where anyone could just take go/whatever, and you can self-service, create your own thing, your own URL that it goes to. And here's an example I like to think, maybe I'm super biased, this is a great name because it both tells you where to go as well as what it is. So it's, Go Data. This is our page. Whenever you're not sure where to go to Go Data, and that'll tell you about the Netflix data platform. My goal, because I don't want to be selfish, is that over time it becomes data everywhere at Netflix. So it'll be more of a map to other things, and then quickly dive down into specifics on the platform as well. It covers tutorials and quick little recipes. It covers DataU, our developer education, and then big data support. We've sort of gone the way of Slack, like most of you folks, and so it's become our one-stop shop. This is there's always trade-offs on how you do support. We had a lot of Slack channels. Most of it we've collapsed down to one, at least for when you're not sure exactly what to do. And this ties into the key roles. So the key roles are, we have developer education. As I said, I hired 2 people that focus just on education right now. They're really diving into it with the subject matter experts and our users. We have a first responder. So this is a role you might not think about at first, but when we initially had our big data support Slack channel, nobody was really on the hook. And that meant that everybody was on the hook and nobody was on the hook at the same time. So people are sort of should I be responding? Shouldn't I be responding? Or nobody would do it and the users were confused. So it's really important to have somebody that knows they're on the hook, and that spares everybody in the end. You should also have sub-team on-calls as well, because that first responder is not going to be an expert in Spark necessarily, and unless it happens to be the Spark person was the first responder. So you should have someone they can route things to quickly. And then the latest one, this is mad scientist formative at this point, is a virtual team I'm creating called a platform partners team within my team. And this is one sort of expert per sub-team. And the goal is that when somebody wants to build some overlapping data infrastructure outside of my team, this is who they would talk to and say, hey, by the way, I'm about to build this huge framework on something. Is this a good idea? And they might say, no, we actually have Spark, by the way, did you know that? Or it could be, that's a great idea, we had never thought about that, and it's a great idea, we would have loved to do it, but we'll never have the time to do it. So it's not a team that says no, it's a team that you want to talk to at the end of the day, because they'll either provide lightweight consultation, or at the minimum, we will have context on what you're doing, or we might say we should really build it, or it could be somewhere in the middle. So I have high hopes for this team. And then finally, the principles and approaches on the education front is that it's important to have clarity all around. That was like the big data support example that I was giving, is that knowing where to go, first off, like there is a specific channel for this, and that somebody's on the hook to respond. We haven't gotten this quite right yet, but we should make sure that people are good at it and like it. Right now it's a distributed load across the team, but we might have someone dedicated to first responder so that they just actually enjoy it, and then they build the muscle over time. They know who to route things to, or they create recipes for common problems, or they know to make sure that they dig into what is the real problem versus what's being asked. Make sure you drink your own champagne, the sort of modern version of dog fooding your stuff. Where we as a platform team should use the data platform, experience it, feel the pain points. And then through that, you establish paid paths. So the gold standard, everything I want in the documentation, what I've been pushing the developer education people on, is this should be what you would do. Because otherwise, it's a treasure hunt. You're trying to figure out where to go and how to do it, and it's like, oh, here's a toy example. Don't actually do it like this. Like, that's terrible. It should be like, if for this use case, this is how you do it. But it's probably gonna be branching narratives, like different scenarios, or even like, here's extended reading or the like. But these are really, really important for efficient data platform. So that's it. With that, thank you very much. I appreciate your time.